gives me great pleasure to introduce Michelle Ashamemri, American aerospace engineer, aerospace entrepreneur, commercial pilot, speaker, influencer. You know, a few years ago, none of us would talk about being influencers. Now everyone knows that word. She was born in the United States and spent a few years of her early life in Saudi Arabia, in the kingdom, and that's where I understand the fascination with space started. Michelle is the first female aerospace engineer in the Gulf Corporation Council and a very successful space technology consultant. So with that, I give you Michelle.
They got me a step because I'm too short. Thank you so much for that introduction. And I'm going to try to keep this as brief as possible because Penny said if I won't, she's going to drag me off the stage. So with that, well, I guess they're still trying to load it up. But first of all, thank you so much for being here. I'm really honored. And I have the pleasure to be among really amazing women today. Unfortunately, I will not be discussing women topics. I will be discussing technology topics, which are mainly gender agnostic. So with that, can we put my presentation on? All right, let's get started. So many of you maybe have been here for a few days, probably listened to a bunch of technical people or people in the industry or policy. And they're all talking about land, air, and sea. Today I'm going to be talking to you about defense in space and its cross-cutting technologies, so how technologies can feed both the defense need as well as the civil need. And also I'm going to take you on a more futuristic look, so I hope you enjoy this. With that, I created this video for your enjoyment. We all know that modern humans began their migration around 60,000 years ago and kept going until they reached all corners of the world. The rate of migration was dependent on climate, resources, social pressures, and transport technologies. So what makes certain regions more valuable than others? The resources they have, such as water, food, minerals, oil, and natural gas. Once these resources are identified, they had to be protected, using the enforcement of borders and defense using weapons. The need to defend these resources and borders led to the development of militaries and weapons. So far, our needs have been earthbound, until the first satellite Sputnik was sent to orbit Earth. From then on, we began to increase our achievements, space assets, and advanced technologies in space. Once we've placed assets in space and became heavily dependent on them, they became potential targets that need to be protected. In addition, significant research has led to the discovery of water and other minerals on the Moon, Mars, and asteroids. These space resources will enable us to manufacture in space and provide the fuels necessary to facilitate deeper exploration of our solar system and beyond. While rockets, spacecraft, and space rovers have advanced so much, space governance and law has been stagnant. With the weak authority of the current fragmented space law, reduced mission transparency, increasing value of space assets, and greater competition in space, the need to defend in space becomes very apparent. A new race is upon us to achieve more in space than ever before. This time, with many nations aspiring to set up bases on the Moon and mine its resources. While most of these endeavors will be for civil purposes, namely science and exploration, one cannot deny the strategic defense significance of cislunar space. Therefore, The race is on. Whoever gets to the moon first will have certain privileges over strategic military real estate. After all, we have seen mankind's historical behavior on Earth. Why should space be any different? Thank you. So that kind of gives you like a quick rundown of what's up and what's going on up to today. But before I get into it, I was like, let me give you some historical perspective, because we're here at a defense show, right? Defense generally pushes the technology further. We've heard today from Rima Bukhalid about the internet. We've heard about the GPS, which most of you probably used to get here. Those were actually developed for military purposes. But I also wanted to highlight some technologies that were developed that maybe some of you did not know that had actually a defense purpose first, that then became mainstream. Many of you enjoy sunglasses, especially in a place like this with a bright sun. So aviator sunglasses were actually developed to protect the eyes or banish the sunlight for pilots. So guess what? Many of you are familiar with Ray-Bans. Why do you think the name was called Ray-Bans? Because they banish the sun's rays. So that technology that you use every day was actually developed for pilots, for defense need. The Jeep, many of you know the car Jeep. So originally it was developed as a light reconnaissance vehicle for World War II. And what happened is that once the World War II ended, they had such a large surplus that they had to get rid of them. So it became mainstream. Originally it was called General Purpose Vehicle, short GP. That's how it came with the name Jeep. So it's pretty interesting that this stuff was actually, that you think is like just a regular car, was actually for defense purposes. Microwave. Many of you most likely will use a microwave to at least pop popcorn. So that technology was used for radar to detect your enemy. What happened is a Raytheon engineer had a candy in his pocket. And while he was playing around with microwaves for radar purposes, he realized that his candy melted. He's like, holy smokes, this thing can heat food. Guess what? We can use this for mainstream. In 1954, it became mainstream everywhere. And so back then it was the size of a refrigerator, by the way, so now it's like really miniature. And then I'm not gonna go over GPS because Rima Bukhalid talked about it. Also the internet many of you are using was actually because they wanted to have a way so that you have the ability to share information without having one localized command center, so that if you get targeted, that you're not gonna lose all forms of sharing information. Virtual reality. In the next probably 2 years, many of you will have this device at home. You will be doing your meetings in the metaverse. You will probably go to a cafe and meet your friend in the metaverse. VR, I remember in the 90s, I used that when in Miami, they had a VR place to go play games. But then I don't know what happened to it since then. But it really was developed for, when you wear it up above your head, for fighter pilots to learn, because it's too expensive for you to fly the plane, especially with 30,000 hours operational cost. So this is much easier. So that kind of gives you an idea that stuff begins as defense for a defense purpose, then gets pushed into the mainstream. So now what's the situation in space when it comes to defense? You see, defense is a critical place where economy and military superiority are very, very important. Why? Because as I've shown in the video, when you have resources, you have economy, you're gonna have a threat to that because you wanna control that and someone is gonna wanna get it from you. So guess what? You're gonna need to develop defense in space. Currently, many countries have invested significant amount of money into counterspace weapons. For those of you that are not familiar with the term, this is basically ways for you to attack someone's space technologies. What is the purpose of them? The 3 Ds: degrade, disrupt, and destroy the space system. What's the purpose of these space weapons? They vary in type based on the effects that they can pose on your technology or space asset. They are different in the way they are deployed. In other words, how are you going to deploy this weapon? They are also different in the methods in which you can field them outside. So with that, let's take a closer look at the different counterspace weapons. I'm going to move away from here if you guys don't mind. I'm not a stationary speaker, so ooh, clearly I missed that one. So counterspace weapons, basically we have 4 categories. We have kinetic. We have kinetic meaning like you actually have a physical contact and physical result. And then you have a non-kinetic physical, which has a physical effect, but there is no contact. And then we also have electronic and cyber warfare. Electronic basically will attack your uplinks and downlinks, so you can use jammers and spoofers. And then cyber, as you're probably all familiar with, it attacks the data itself, so you can either seize the data, remove the data. All these technologies exist today and have been put in use. As a matter of fact, last week, jamming of the Starlink happened for when those satellites were used in the Ukraine. So Russia actually attacked them. And then obviously there's a lot of cyber stuff going on. So this stuff is happening currently. So this space war is really up among us right now. So I'm not making up stuff. And also, by the way, with the kinetic physical, direct ASAT is one of the most destructive because it causes so much debris in space, and that's a problem for a lot of satellites and a lot of assets that you want to send to space. There's also, so you either send something from Earth to go attack a satellite in space, or you actually have a satellite in space, what's called co-orbital ASAT, that shoots out something, like imagine a satellite that shoots out another projectile, shoots your satellite down, that's another physical type in space. And then obviously you can attack the ground stations here. So now we've talked about what is the current situation, we've talked about how defense pushes the envelope when it comes to technology. What's next? All of you have heard that the moon has a lot of water in the form of ice. Guess what? Certain areas have higher densities than others of this frozen water. That becomes what? A resource. When you have a resource, guess what's going to happen? You're going to have people seeking out that resource. Whoever gets it first will have to be like, it's mine, don't touch it. So no matter what happens, no matter what you want to say, that, oh, we are political, it's easy, the threat is there. So the next step is lunar, and the reason why it's the next step is because there's a resource there that we are going to use and we're going to mine, especially because we have China and the US trying to put up bases, and they're trying to have many countries collaborate with them on those bases. So basically, whoever gets there first has control of strategic military real estate. So now let's talk about a little bit about the future stuff. What is the most important thing that you are going to have when it comes to going to cislunar space? So cislunar is the space between Earth and the moon. That location or that span is actually cislunar space. When you have information, you have a competitive advantage. So the most important thing in order for you to set up an economy is basically information dominance. How are you going to get that information dominance? Through cislunar technologies, cislunar space domain awareness technology. How are you going to do that? So you're going to need to develop all these weapons that will enable you to have situational awareness, meaning I can see what's going on, I'm always informed. I can find out if there's a threat so I can prevent it, and it gives me enough time for me to respond when I see that threat, because if you have a lot of information in advance, you'll be able to respond properly. In addition, you're going to have to, because if you're going to set up all these technologies and have all this information, you're going to be the one that's setting up norms of behavior. That is very critical when we talk about space and space defense, because the moment you do something wrong and you set the stage wrong, then you are basically allowing everybody else to do something wrong. So if you're the first and you take responsibility to be the first, then you allow that norms, you set up the norms of behavior in that space. And then sustainable space, when you have a lot of threat for attack, or like for example, any object that's going to hit you and you can respond to it, that's important. With all this technology, you will have information dominance. When you have information dominance, you have the upper hand and you have the ability to set up a proper economy. So with that, let's get into the fun stuff. So here, I want you to open your mind and think about what do we need for this sort of thing, and most importantly, how do these technologies can be used for defense and for civil purposes.
One of them is lunar mining. Obviously, we have this water. We're going to need to extract it. You're going to need to mine to extract the stuff. There's also other minerals that we're looking for on the moon. So we're going to be able to extract it. Why? Because number one, if I want to set up an entire ecosystem, and if you want to travel through space and you want to set up a base and so forth, water is fuel. Because water, you have hydrogen and oxygen. If you use electrolysis, you extract hydrogen and oxygen, and guess what? That's what I'm going to use for fuel. So they're very critical, they're very high in demand assets for space. Then, this lunar mining will feed into who's going to need fuel. We're going to need fuel either for missions that are defense-based or civil purposes, like if we want to explore, if we want to go deeper into space, we use these lunar mining capabilities, which I will have another technology that will use this, but I will describe it in a minute. Lunar PNT. Just like you have your GPS here on Earth and you enjoy moving around, guess what? Lunar PNT, position, navigation, and timing is going to be critical for you to understand what's up and what's going on. Fission surface power. This is a technology that's near and dear to my heart, because guess what? Do any of you know how long it takes the moon to rotate about itself? Any takers? Guess. Wild guess. Close enough. 27 point something days. So guess, that's why we only see one side of the moon. What does that mean? It means that I have 14 days of darkness. So if I have something that relies on solar power, I'm going to be SOL. I'm not going to get power. So fission surface power is a modular fission reactor that is used to convert the heat from the fission reaction into electricity. So these are modular because I want to be able to ship it to the moon, put it under the ground, and use that power for me to be able to mine and do all the fancy stuff I want to do. Next up, this one is really crazy, but I love it. Space-based power beaming. So basically imagine I can send you power, just like free power, from the sun. I don't need to do anything. I put large solar panels, extract the sunlight, and then beam you energy from using the electromagnetic spectrum. Whatever type of wave you want to use, but I just beam the energy. You know how amazing that technology would be? And that technology is actually being worked on. So it enables me to have spacecraft that don't even need to have the power systems on them. I can just beam the energy, they receive it, and they use it, but they don't have to carry a power system. That means my system will be a lot cheaper for me to launch from Earth. So that's pretty cool. And then you can use that to beam power on Earth even. And especially in remote areas, you can use it on the moon too, depending on where you want to put it. So I would presume L2 for this one, because then you need access to the sun at all times. Space-based propellant depots. This is like a gas station in space. Why is this important? I'm trying to go to Mars, right? Whether I'm doing it for defense purposes or civil purposes. I'm going to need to refuel because I don't want to carry all that fuel because it costs me money to carry heavy stuff. I carry whatever I need to rendezvous with this guy, refuel, and then continue. Seems logical to me. So then you can use power, or you can beam it power, or you can even use nuclear energy to power this thing. So many ideas out there. But this is where we're headed. And this obviously will feed into either defense or the civil area, because both of them are going to need this technology. Next up, in-space manufacturing. Why is this important? In-space manufacturing makes things a lot easier for me. You know why? Every time I launch something from Earth, I'm going to need to make sure it can withstand the vibration. I need to make sure it can withstand the G's as the stuff comes out of Earth. We have a large gravity, so therefore I need a lot of fuel. I have a lot of G's to get out of here. So that means I have to make it super robust. When I make it super robust, what's going to happen? The weight increases, meaning I'm going to need more fuel. It's like a whole cycle that keeps hitting you, so you're going to have to optimize all the time. In space manufacturing, I don't need to worry about that stuff. I don't need to make it that robust because I'm manufacturing in the environment in which it's going to need to work. So I can remove all this stuff from it. And there's no aerodynamics there, so it's pretty cool. So then this is very important. Extremely, extremely important for both defense and the civil side. Satellite servicing. This is actually a technology that exists today. As a matter of fact, Northrop Grumman tested it multiple times with the MEV, the Mission Extension Vehicle. This type of technology definitely has dual-use purposes, and I will give you the two scenarios. But first, they actually, last month, received the first commercial use for this particular product, the MEV, because before that they were demonstrating it. This time they actually have someone that paid them to be able to do the mission extension vehicle. Why is this? Can anybody think of how this could be used for a defense purpose? No. You have a robotic arm, right? And you have the ability to service a satellite. I go rendezvous with a spacecraft. I use the robotic arm to capture it, or however mechanism I want to use. Attach myself to it, deplete it of its fuel. Done. Killed the whole thing. So and then at the same time, I can rendezvous with the spacecraft, refuel it, and extend its mission life. So it's like, one of those double-edged swords. Next up, my favorite two topics. High-power electric propulsion. Nuclear thermal propulsion is like the love of my life. But let's talk about electric propulsion. High-power electric propulsion is critical, especially if you're doing high-energy maneuvers when you have time, not necessarily your restriction. This technology becomes increasingly crucial for military maneuvers in certain spaces and certain inclinations. Because one, it is the most efficient type of propulsion system that we have. For every 1 kilogram of a payload I'm carrying, I only need 73% of that weight as fuel, which is unheard of in chemical. In chemical, you need 10 times whatever your per 1 kilogram of fuel. And in nuclear, you're going to need basically 2.4 kilograms for every 1 kilogram of fuel you're carrying. Extremely important, very high power, very low thrust, but that's what is going to be the next frontier for this type of technology. Nuclear thermal propulsion. If you want to go to Mars, your best bet is on nuclear thermal propulsion. The main problem that's been delaying this technology, and this is not new, the concept is pretty old. The main problem is public perception, the use of highly enriched uranium. So I'm not going to get into the details of that, but let me just make it simple. If you use high enriched uranium, the system becomes smaller. But if you use low enriched uranium, the system becomes much larger, meaning it means heavy, meaning it's going to be difficult for me to send to space. But if you want to have, for example, let me give you some ideas of where we're going to use this. To send humans to Mars, this is the technology you're going to be wanting to use because it reduces the time to get to Mars in half. So, because when I send humans to Mars, I'm worried about the time exposure to microgravity and radiation. For electric propulsion and this guy, you are familiar with frigates, right? Space frigates, powered by nuclear electric propulsion and nuclear thermal propulsion. Or you can even have a space tug that's using both technologies, because whenever you need high thrust, you turn on this engine. When you need just basically high velocities, you use this engine. So these are the types of technologies that are going to fuel our future and that can have dual use purposes, which is wonderful, because if it has defense purpose, guess what? It's going to get funding. So to finally get to this point, which is wrapping up everything, and I hope I didn't take too much of your time, but basically what I want to say is that space defense is really critical to secure your future in space, to secure your assets in space, and to securing your potential contribution in the economy. And I want to highlight that, yes, whoever gets to the moon first will have strategic military advantage, but they are really responsible. They have to understand that they are very responsible in setting up the norms. It will showcase your space capability and superiority, but it comes with the responsibility that you are representing all humankind, no matter what you're trying to do. Therefore, it comes with a huge responsibility. So you need to set those norms. And with that, I want to thank you for your time.